Okay, so this is pressure. So pressure is an interesting thing. It's what I prefer to call like a piercing force. It is shown here. It's quite interesting what pressure can do. Pretty easy. We've got the exhaust fumes coming out of this pipe, and it's able to lift up the car. So pressure can be very strong in certain situations, and the reason for that was pressure is essentially the ratio of force over area. Now, this essentially says that the greater the top line, the greater the pressure. Or the smaller the top line, the smaller the pressure. Okay, so smaller the force, smaller the pressure. Because you're making this fraction larger or smaller. So how can you change the pressure larger or smaller, or the fraction larger and smaller, by changing the area? So what you can do, well, if you increase the area, you actually get a smaller pressure. If you decrease the area, you actually get a larger pressure. So what is it also? I'll call it like the piercing force. It's the force that you generally actually feel. Okay, so if you push your pen against your skin, the indentation is created by pressure, not by the force itself. Because you can keep the same force, but if you have a different pen, you could change the indentation. So you can see here we've got two physics books. They both have the same weight. So they both push with the same force. Okay, so they're both pushing down with the same force on the bench. Now, because they have the same force, you could say they have the same pressure, but they don't, and that's because the areas of where they contact with the table are different. So this book here has the greater pressure because it has a smaller area. When you use a pin, you usually push on this thing and you use your thumb. It's a funny looking thumb. Okay, it's more like a toe. So that thumb pushes on there. Now the reason why the pin doesn't go into your finger is because it has a large area. However, if you pushed on this end, it's more likely that you will have the pin go into your finger with the same force. That's because it's got a smaller area. The classic bed of nails trick, okay? If you lay down on a single nail in a bed, okay, so here's a person laying down on this single nail, then they probably wouldn't survive. However, if you had many nails, they would be okay. And the reason for that is the single nail has that area, but then if you're looking down on it and you have many nails, then you add up all the areas and you're actually increasing the area. So the same force, there's less pressure, so there's less chance of it piercing the skin. Hence why we hammer nails with a small head. Okay. Here's a syringe. Okay, 2 syringes. One's got a large area, one's got a small area. This one will have the greatest pressure flow because the same force has been applied to a smaller area. Okay, so force over area ratio. Force over area ratio, we have a smaller area, so this whole fraction must get larger. Last example, walking in snow, small little feet, large pressure, snowshoes at the bottom of your feet, spread the load or increase the area so there is a smaller pressure.